Hey, how's it going? So for the skill that we're going to be covering now, it's going to be adding, subtracting, and multiplying polynomials. So for each problem, we're going to have an adding and we're going to have a subtracting one. And then as we progress through, then we'll look at multiplying. So when it comes to adding, when you add polynomials, look at it like combining like terms. So if I have 4x squared minus 7x plus 10 plus 2x squared plus 4x minus 8, you're looking for like terms. So for example, 10 and negative 8, those are both constants because they don't have a variable next to the number. Those are like terms. Negative 7x and a positive 4x, those are both like terms because they both have a variable of x. And 4x squared and 2x squared, those are like terms because they both have a base of x squared. So then when you're adding polynomials, you can kind of drop the parentheses because you don't have to distribute a negative 1 like you would do in the subtraction problem that we'll see shortly. So from here, as you can see the color coding, you can go ahead and just combine like terms. So what do I mean by that? Having 4x squared plus 2x squared. All right, and that will give you 6x squared. The most common mistake here is we would add 4x squared plus 2x squared and get 6x to the fourth. When you add and subtract, you do not change the exponents, you do not change the base. You just add, subtract the coefficients, and you bring the same base along with it. All right. So if you look at negative 7x and a positive 4x, if I type in negative 7 plus 4, I should get negative 3. So hence negative 3x. And if I have a positive 10 plus a negative 8 or 10 minus 8, however you want to read it or say it, that will give you a positive 2. So then this will be our final result. And as a reminder, when you're talking about adding, subtracting polynomials, if you know that this is your original problem and this is your final answer, if I type in this original problem in the Desmos and I type in this final answer in the Desmos, it should give me the exact same graph, just a way to be able to kind of check your work. All right. So now let's go ahead and look at subtraction. It's the same polynomials, but we're going to be subtracting instead of adding. I want to hop right to the piece that's going to change. So the first parentheses is going to stay the same because you don't have a coefficient, or technically you have a coefficient of 1 out front, so that doesn't change these values. This second parentheses, this is like having a negative 1 right here. So then you have to distribute that negative 1. When you distribute a negative 1, that's like multiplying negative 1 through all these terms, which is also like changing all of these signs. So negative 1 times 2x squared is negative 2x squared. Negative 1 times 4x is negative 4x. Negative 1 times negative 8 is a positive 8 here. All right. So from here, you combine like terms like we did in the adding one. The only thing different is when we subtract, we have to not forget to distribute this negative 1 throughout this parentheses here. And if that was a negative 2 or negative 4 or positive 5 out front here, I would have to distribute that all the way through. All right, so now I can just combine like terms. So you can see our like terms. We got 4x squared and negative 2x squared, negative 7x and negative 4x, and then 10 and a positive 8. And once you combine those like terms, this should be our final result. So we're going to look at a couple more examples. So when it comes to adding here, if there's no number written out front of this negative x, this is like having a negative 1x. All right, so because we're adding, and we don't have a number to distribute through other than 1. Like if I had a 2 here, I would have to distribute that 2 throughout. So 2 times each one of these. Or if I had a 3 and so forth. Well, because I don't, I can just go ahead and drop the parentheses and combine like terms. So you can see the sets of like terms that we have. Once we group them together, we can go ahead and add them or subtract them however you view it. So 13 minus 5 gives you 8x squared. 4 minus 1 here gives you 3x. And negative 7 plus 2 gives you negative 5. Now with subtraction, there's a coefficient of 1 here, so we just bring this first parentheses down as is. And because we have a negative, this is like having a negative 1, so we have to distribute that negative 1 throughout this whole right parentheses. So negative 1 times negative 5x squared, negative 1 times negative 1x, and negative 1 times 2. And once I do that, I should get 5x squared at 1x and a negative 2 in this right parentheses. So now I can go ahead and just combine like terms, go ahead and group the like terms. Then once I add 13 and 5, I should get 18x squared. 4 and 1, I should get 5x. And negative 7 and minus 2 gives you negative 9. Once again, when you add and subtract polynomials, you do not change the bases. You're just combining the like terms. So you're adding the coefficients. You're keeping the bases the exact same. Now, what happens if you're adding, subtracting polynomials, but you might have an x squared term over here, And over here, but you might have an x term over here, but not have an x term over here. How do you do that? All right, that just means you don't have a like term to combine, and you'll just bring it down as is. But we'll go ahead and look at this example now. So 2x squared minus 5, I just bring that down because I don't have a coefficient to distribute here. And I don't have a coefficient to distribute here either, so I'll bring that 7x squared, negative 2x, and a positive 1. So if you look at the color coding, you see we have some like terms. We have a 2x squared and a 7x squared. We have a negative 5 and a positive 1. There's only one term that has an x. So that means you don't have a like term there. You just bring it down as is. So when I combine like terms, I have 2 plus 7 is 9, so I have 9x squared. Negative 5 plus 1 is negative 4. And I just bring down negative 2x because I don't have a like term for that. All right, I only have one term. So if we look at the next problem, we can go ahead and bring this first parentheses down as is because we do not have a coefficient out here. If we did, we would have to distribute that. So this is like having negative 1. Negative 1 times 7 is negative 7. So negative 1 times 7x squared, is negative 7x squared. Negative 1 times negative 2x is positive 2x. And negative 1 times 1 is a negative 1. From here, group our like terms. And notice that we don't have a like term for the x term. We just bring down positive 2x as is. And once we add straight down, we should get negative 5x squared plus 2x and then negative 6. All right, so then now let's go ahead and add and subtract these sets of polynomials. We have negative x squared plus 2x minus 3. There's no coefficient other than 1 out front, so we can go ahead and drop that first parentheses. And then when you look over here, you have a adding, and you're adding a negative 4x minus 5. Don't just bring down this positive here. Because this is a positive 1, it does not change the signs here. So that's like a positive 1 times negative 4x, which is negative 4x. A positive 1 times negative 5, which is negative 5. A common mistake here is that we will want to write plus 4x. All right, so now you can see the sets of like terms that we have. We only have one x squared term, so we know we're going to bring that negative x squared down as is. But you have two terms that have a base of x, positive 2 and a negative 4. So once I add 2 and negative 4 together, I should get negative 2, so negative 2x. And then I have another set of like terms, which are my constants, which is negative 3 and negative 5. So once I add those together, I get negative 8. I say add because technically you could take negative 3 plus negative 5, or you could just say negative 3 minus 5. However you want to do it, either way, it should give you the exact same result. So if you look at the next example, there's a coefficient of 1 out here. So because the coefficient of 1 is not going to change its value, so you'll just bring down this first parentheses. And then because this is a negative 1, this is like having negative 1 times negative 4x. Now it's going to be a positive 4x. Negative 1 times negative 5. Now that's going to be a positive 5. As you can see, based off the color coding, you can see the like terms. So we don't have a like term for the negative x squared, so we just bring down it as is like we did in this earlier problem. And then we have 2x plus 4x, which gives us 6x, and negative 3 plus 5, which gives us a positive 2. So then this will be our solution. So now, sometimes it'll be adding, subtracting polynomials straightforward like you just saw in the last several examples. But then sometimes you might see it written as find the perimeter. All right. So if we want to find the perimeter of this figure, you're still adding polynomials. So if this side was 2n plus 1, this side is 2n plus 5, this side is n plus 5, as you can see written here. So this is the expression that represents finding the perimeter of this figure. So from here, I'm going to go ahead and combine my like terms. Because we have coefficients of 1 in front of each one of these, it doesn't change any of these values, so I can just bring them down as is. So then, from here, I can group my like terms. So I have 2n, 2n, and n. Remember, that's like having 1n. So 2n plus 2n plus 1n. 2 plus 2 is 4, plus 1 is 5, so we should have 5n. And then our constants, 1, 5, and 5, when I add those together, I should get 11. So I should have 5n plus 11. And then that is the perimeter of this figure. Now, what happens if you have a rectangle? So when you see these dashes here, this just means that this side is the equivalent to this side because they have the same number of dashes. When you see 2 here, that just means this side is equivalent to this side. They have the same number of dashes. So if I want to find the perimeter of this figure, I'm going to have 2t plus 1 plus 6t plus 5 plus 2t plus 1 because that's what this measurement is, plus 6t plus 5 because that's what this side measurement is. One of the common mistakes here is we'll add these two together and we will say that's the answer. All right, but that's only half of the perimeter. So then now, as you can see here, we're going to group our like terms. So I have 6t plus 6t plus 2t plus 2t, which gives us, what is it, 12 plus 2 is 14, plus 2 is 16t. And our constants is 5 plus 5 plus 1 plus 1, which gives us 12. So 16t plus 12 is the perimeter of this figure. All right, and then our last one for perimeter. You have one dash on each one of these sides. So what that's telling you is all of these sides are the exact same measurement. So in order to find a perimeter, I need 7r plus 2 plus 7r plus 2 plus 7r plus 2 plus 7r plus 2. All four sides are the same measurement, so it would look like this. And then from here, when we group the like terms, we would get 28r. And then when we group these like terms, when it comes to our constants, we should get 8. So we should get 28r plus 8. And that would be the perimeter of this rectangle, this square here, while this is the perimeter for this rectangle, and this is the perimeter for this triangle. So now we're going to look at multiplying polynomials. Before we look at multiplying polynomials, let's get a little review. We have a 3 plus 3, we know is 6. 3 times 3, we know is 9. Now let's look at variables. X plus x, like we looked in the previous problems, that's like 1x plus 1x, which is 2x. But when you multiply with the same base, you add the exponent, so that would be x squared. So now all of a sudden when you multiply, you add the exponents, unlike what we did when it comes to adding and subtracting. Now if I have 3x plus 5x, like we did previously, 3x plus 5x is 8x. And then when we have 3x times 5x, that gives us 15x squared, because you multiply the coefficients, 3 times 5, and you add the exponents for the base. So you have x to the first times x to the first. So that's 1 plus 1, which gives us 2, x squared. Now 5 times 4, we know is 20. 5 times 4x is 20x. What I want you to think about here, when you multiply, 3 times 5 we know is 15. Together, how many x's do you have? You have 2, so it'll be x squared. So when you're multiplying here, 5 times 4 is 20. Between both of these terms, how many x's are present? 1. So it needs to be 20x. 5x times 4, 5 times 4 is 20. Between both of these terms, how many x's are present? 1. 20x. 5x times 4x, when you take 5 times 4, you get 20. Between both of these terms, you have 2 x's, so it'll be 20x to the second power, or 20x squared. Now let's go ahead and look at multiplying polynomials. So when it comes to multiplying polynomials, we're going to look at the box method. So if you look at the two terms that were the two expressions that we're multiplying, we have 3x minus 7, which has two terms. So that's why I put two boxes at the top. And then times 4, which is just one term. That's why I have one on the side. Like if I had 3x minus 7 times 4x plus 1, then I would have two boxes over here, which we're going to look at some examples for that in a few minutes. So now after we create this box method, now each box is a multiplication problem in order to get what value goes inside of it. So to go inside this box, we'll take 4 times 3x. 4 times 3 is 12. We have 1x in between those two. Negative 7 times 4 is negative 28. And that's your final answer. So it can be done with 3x minus 7 at the top and 4 on the side, or you can flip it and do it the other direction where you have 3x minus 7 on the left side and then 4 at the top. As you can see here, it's going to give you the same result. So now what happens if I have 3x times 5x plus 2? The structure is actually going to look the same because 3x is still one term polynomial, which is a monomial, and 5x plus 2 is a binomial. So I'll have two boxes at the top. And it doesn't matter if you flip it this way as well. So in order to find out what goes inside of here, we need to multiply these two terms. 3x times 5x. 3 times 5 is 15. Between those two, we have two x's, so it'll be x squared. 2 times 3x gives you 6. 2 times 3 is 6. You have one x in between those two, so you have 6x. Those aren't like terms, so we can just go ahead and write that as our final answer. Now, like on the previous problem, you can write it vertically as well. It'll still give you the same result. So now, let's look at a binomial times a binomial. A binomial is just a polynomial with two terms. So now when you create your box method, it'll be a 2 by 2 box. So you have 2x and then a positive 4 and then 3x and a positive 5. So if I want to fill out what goes in this top left box, that's 2x times 3x. 2 times 3 is 6. Between those two terms, you have 2 x's. So it'll be 6x to the second power. All right. And then if you look here, this 12x came from 4 times 3x. This 10x comes from 2x times 5. And then this 20 comes from a positive 4 times a positive 5. Now notice here you have like terms. You have a 12x and you have a 10x. Because you have like terms, you have to simplify that as well. So now it kind of goes back to adding, subtracting polynomials. So 12 plus 10 is 22x. Make sure when you add polynomials, you do not add the base. You add the exponents when you multiply up here, but when you start to add, you just add or subtract the coefficients and keep the base. All right, so then 6x squared plus 22x plus 20 is our final result here. So now if you look at 5x plus 7 times 6x plus 2, it's a 2 by 2 box. 6x and a positive 2 and 5x and a positive 7. And once again, you could have put 5x and a positive 7 at the top and then 6x and a positive 2 on the side as well. It would have been the same either way. So if I look at this top left box, this would be 30x squared because I got 6 times 5 is 30, and then x to the first times x to the first is x squared. All right, but another way you can think of it is just how many x's do you have in total. So then if I look at this top right box, 2 times 5x gives you 10x. Bottom left box, this should be 42x because we have 6x times 7. 6 times 7 is 42. And between those two terms, you only have 1x. And then this bottom right box, we have 2 times 7, which is simply 14. Now we write our answer down here because we wrote all 4 terms. But we notice that we have like terms. You have 2 x terms. So you have a positive 10 and a positive 42. So once you combine those, you should get a 52x here. So then this would be our final result. So let's go ahead and look at 2 more. So if we look here, we have 9x minus 1 times 8x minus 2. And then you have, fill in the top left box, that'll be 72x squared because you have 2 x's in between those. And then this would be negative 18x. This would be negative 8x. And this would be a positive 2. Please watch your signs here. Negative 2 times negative 1 is a positive 2. Now, when you look here, you have like terms. Negative 18x minus 8x. Negative 18 minus 8 is negative 26x. Not positive 26x, not negative 10x, not even positive 10x. Negative 26x. So now let's go ahead and look at this problem over here. So x minus 2. Notice that I brought that negative 2, that negative with the 2. The sign is in front of the value. It's in front of the term, I'm sorry. And then you have negative 3x and a positive 4. It's like having a 1 out front of this x if it's not written. That's like having 1x to the first power. Just like that is having negative 3x to the first power. So when I multiply and get this box to the top left, this will be negative 3 times 1, which is negative 3. And you have 2 x's in between them. So it'll be negative 3x squared. And then we have 4 times x, which is 4x. Negative 2 times negative 3x. Negative 2 times negative 3 is 6, positive. And you have 1x in between those. And then 4 times negative 2 is negative 8. So now when I combine like terms, I have a positive 4 and a positive 6, which gives me a positive 10x. Now what happens if you have a problem that looks like these? This says x minus 4 squared. What does that mean? That means x minus 4 times x minus 4. So we just do our same box method. All right, as you can see here. And then so x times x, that's like having 1x times 1x. 1 times 1 is 1. You have 2x's, so 1x squared. And you have negative 4x, and a positive 16. Positive 16 comes from negative 4 times a negative 4. All right. And then now you have like terms. This is negative 8x, not 0. All right, that's negative 8x when you combine those. Now, if you look at this next example, you can kind of understand where we're going with this. It's 2x plus 7 times 2x plus 7. And then this top left box is 4x squared because you have 2x in between those two terms. And then we have 7 times 2x, which is 14x, because you only have 1x in between those two terms. 2x times 7 is 14x here, and then 7 times 7 is a 49 here. And then now I have like terms. Combine those like terms, and I should get 4x squared plus 28x plus 49. Similar how sometimes when it comes to adding and subtracting polynomials, they'll ask you for the perimeter. When it comes to multiplying polynomials, sometimes they'll ask you for the area, because you have to multiply in order to find that oftentimes when it comes to a rectangular square. All right. So now, what is the area of the garden below? One side is 3x minus 4. The other side is 5x plus 2. So you will multiply 5x plus 2 times 3x minus 4. So we'll go ahead and create our box. And then from here, we'll do what we've been doing. So we'll get 15x squared here, negative 20x here, 6x down here, and then we will get a negative 8 here. Now we can go ahead and rewrite it, and we have like terms, so we need to combine those. Negative 20x plus 6x. Negative 20 plus 6 is negative 14, so that should be a negative 14x as that middle term here.